In this video, we are going to look at geometry theorems. The first three theorems we will call angle theorems. Then we will look at parallel line theorems. And finally, we will look at triangle theorems. The first theorem we are going to look at is called the supplementary angles theorem, or SAT for short. The supplementary angle theorem states that two angles that add to 180 degrees are supplementary. Looking at this example, we see we have angle X and angle 40. These two angles are supplementary because they lie along this straight line here. So we can say that X plus 40 is equal to 180 degrees. This is a simple equation that we can solve by subtracting 40 on each side. So we know that X has to be 140 degrees due to SAT, the supplementary angle theorem. The complementary angles theorem, or CAT for short, states that when angles create a right angle, their sum is 90 degrees. Looking at this example, we have a 90-degree angle that is split into two angles, X and 62 degrees. So we can say that X plus 62 is equal to 90. And then again, this is a simple equation that we can solve by subtracting 62 from both sides. And we are left with X is equal to 28 degrees. And we know that because we use the complementary angle theorem. The third theorem, called the opposite angle theorem, or OAT for short, states that when two lines intersect, the opposite angles are equal. So in the example, we see two lines crossing each other. One of the angles is given as 60 degrees, so we know that the angle opposite is also 60 degrees. So X is equal to 60 degrees because of the opposite angle theorem. We are also able to find the other two unknown angles if asked. So we can call this top angle, let's call it Y, and we can see that Y and 60 degrees are supplementary angles. So we can say Y plus 60 equals 180 degrees because those are supplementary angles. Subtract 60 from both sides, and we can say that Y is equal to 120 degrees because those two are supplementary angle theorems. As we know what Y is, we can then find the opposite angle using the opposite angle theorem. We know that the angle down here is also 120 degrees. We could have also found that by using 60 with this angle here, as those two angles would have been supplemental angles. The more information you have in a question, the more different theorems that you could possibly use to solve the question. We'll now look at the parallel line theorems. In each of these three theorems, we are given a set of parallel lines, and we know this as there are arrows on each set of lines, indicating that they are parallel to each other. The lines may also go in this direction here, or they could go diagonal like this. As long as they are parallel, these theorems will work. The corresponding angles theorem states that when a transversal crosses two parallel lines, the corresponding angles are equal. The transversal is the line that cuts through the two parallel lines, so it's the third line. So this says that the corresponding angles are equal. So here 60 degrees and angle X are corresponding, and they are the same. The short form for corresponding angles is PLT-F. PLT stands for parallel line theorems, and F comes from a figure F that we can actually draw to show this relationship. So with a highlighter, I am going to trap angle 60. I'm also going to trap angle X, and you can see this F that is formed. The F, just note, the F could also go backwards, or it can go pointing upwards or downwards. So angle 60 and angle X are equal to each other because they are corresponding angles. So we will say x equals 60 because of PLT-F. The alternate angles theorem states that when a transversal crosses two parallel lines, the alternate angles are equal. So again, we have the two parallel lines. The transversal line cuts through the two parallel lines, and we have two angles, 120 degrees and x. These two are alternate angles, and this theorem states that they are the same. Here, the short form is PLTZ. This time, we will draw a Z figure to show the relationship between these two angles. So again, I'm going to trap angle 120 and angle X, and we will see that kind of flattened Z, but you can see that Z shape here. And when you see that Z shape, the two alternate angles are equal to each other. So here X is equal to 120, and that is because of PLT Z. The third parallel line theorem deals with interior angles. The theorem says that when a transversal crosses two parallel lines, the interior angles add up to 180 degrees. So again, we have the two parallel lines, the transversal. This time the two interior angles add up to 180 degrees, unlike the other two parallel line theorems where they were the same. And here we can see x is not the same as 120 degrees. 120 degrees is obtuse and x looks to be acute here. Remember, all of the diagrams are not drawn to scale, but you can see here that these two angles are not the same. So the short form here is PLT-C, because this time we will draw a figure C. So again, we trapped the angle X and trapped the angle 120 degrees, and a C is formed. Again, this can be a backward C. It can be a C that opens up or a C that opens down. So here we would say X plus 120 is equal to 180. I will then subtract 120 from both sides, and we find that X is equal to 60 degrees because of PLT-C. Before we move on, let's just compare the F, the Z, and the C. So for corresponding angles, when drawing the F figure, we notice that the two angles are on the same side of the transversal, but they are both underneath the parallel lines, or they would both be above the parallel lines. They're not inside the two parallel lines, like the C pattern. The C pattern, we have the two angles on the same side of the transversal, but they're both on the interior. That is not the case for the F pattern. And then for the Z pattern, it's a little easier to recognize the Z pattern because the angles are on the opposite sides of the transversal. They're both in between the two parallel lines, but they're on the opposite sides. Now let's look at the three triangle theorems: the isosceles triangle theorem, the equilateral triangle theorem, and the angle sum of a triangle theorem. The isosceles triangle theorem, or ITT for short, states that two angles opposite the equal sides are also equal. So here we have an isosceles triangle, and we know that because two sides are indicated to be equal. That means the two angles opposite those sides are also equal, and I'm going to call them x. We are going to come back to this theorem after we look at the third theorem and complete this example. The equilateral triangle theorem, or ETT for short, states that all three angles in an equilateral triangle are the same, which means that each angle must be 60 degrees. So here an equilateral triangle is drawn. Each length is the same as marked, and so each angle is also the same. So we will call each angle x. And again, we'll come back and finish an example for this equilateral triangle once we look at the last triangle theorem. And the final theorem, the angle sum of a triangle theorem, or ASTT for short, states that the three angles in a triangle sum to 180 degrees. So that is true for any triangle. So here we have a triangle. This is not isosceles or equilateral. It's just a triangle with 3 different sides. And using this theorem, we know that x plus 65 plus 40 must equal 180 degrees. I'm now going to simplify the left side before I start solving this equation. So x plus 105 equals 180 degrees. Then I'm going to take away 105 from both sides, and I'm left with x equals 75 degrees. And I will state the reason is ASTT. So now let's go back quickly to the first 2 triangle theorems and finish those examples. So in the first one, the isosceles triangle, let's make this angle to be 40 degrees. I'm just making up a number to make this an example. Now that I know this angle, I'm able to find these 2 angles, which are both equal. And I'm using ASTT, angle sum in a triangle theorem. I know that 40 plus x, I know all 3 of those angles have to equal 180 degrees because of ASTT. That simplifies to 40 plus 2x equals 180 degrees. I will subtract 40 from both sides to get 2x equals 140 degrees. Then divide both sides by 2. And I know that x equals 70 degrees, and that is because of ITT. I knew these 2 angles to be the same because this is an isosceles triangle. I knew that all 3 of the angles added to 180 degrees because the angle sum in a triangle theorem. So in this example, I actually use 2 triangle theorems. So now going back to the equilateral triangle, we have 3 angles, each are the same. So x plus x plus x, or 3x, all 3 of those angles are 180 degrees because of ASTT. So 3x equals 180 degrees, so just divide by 3. 180 divided by 3 is 60 degrees, and that is ETT. So for any equilateral triangle, no matter how big or how small the triangle is, if all 3 sides are the same, all 3 angles are the same, and they must always be 60 degrees, and that is because all 3 angles sum to 180 degrees.